This question is about the structural isomers shown. So you can see we've got 6 structural isomers. It says identify the isomers that would react when warmed with acidified potassium dichromate. So that's an oxidizing agent that oxidizes primary alcohols, secondary alcohols and aldehydes. So let's have a look through our structures. P is a tertiary alcohol, so that's a no. Q is a primary alcohol, so that's a yes. R is a secondary alcohol, so that's a yes. S is a secondary alcohol, so that's a yes. T is an aldehyde, so that's a yes. U is a ketone, so that's a no. So it's Q, R, S and T. And what we would observe is that the orange solution of potassium dichromate turns green. Identify the isomer or isomers that would react with Tollens reagent. Now that is a specific reagent that only reacts with aldehyde groups, so that would just be T. And Tollens gives us a silver mirror with an aldehyde. Separate samples of each isomer are warmed with an ethanoic acid and a few drops of concentrated sulfuric acid. So this is esterification, acid plus alcohol, so only the alcohol ones would react. So which isomers would react? So the alcohols were everything except the last two, so P, Q, R and S, but not T and U. Identify, suggest a simple way to detect. Well, we should get a sweet smell of an ester. And then it says, give a reason why the mixture is poured into sodium hydrogen carbonate. Well, that's to neutralise the concentrated H2SO4 and remove it so that you can smell it. State the type of structural isomerism shown by P, Q, R and S. Let's go back and have a look at them. So what we've got is a cyclopentane ring with a methyl group sticking off, and then the OH is moving around. It's moved from the sort of one position of the cyclopentane ring to on the methyl group, to the 2 position, to the 3 position. So it's moving around positions on, the functional group is moving around its position on that methyl cyclopentane, so they are position isomers. Describe fully how infrared can be distinguished between R, S and T. Use data from Table A in the data book. So Table A is our infrared data. And if we look at R and S are both alcohols. So would both have the same alcohol OH peak, which we can write down the values for from Table A. But T is different because T is an aldehyde and so would have a completely different characteristic absorption. So we would say T would have an absorption 1680 to 1750 centimetres to the -1 due to C double bond O bond. R and S both have OH bracket alcohol. Remember that there's 2 OHs on the data sheet when we're looking these up. And that this one is 3,230 to 3,550. We do need to say it's the OH in alcohol. But how would we tell R and S apart? R and S would have unique fingerprint region. That's the region below 1,500 centimetres to the -1. And we could compare these to a database to identify them. And then it says, state why mass spectrometry using electrospray ionisation is not a suitable method to distinguish between these isomers. It doesn't really matter which ionisation method you use here. The point is that because they are isomers, they have the same molecular formula, and as a result, they all have the same MR. And so mass spectrometry would be no good to us.